Okay, so welcome everybody, and welcome to this session, which is about Golo. And Golo is yet another new dynamic language for the JVM, so yet another one. Before we get started, I have to say just a few words about myself. So my name is blah 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 Julien Ponge. I'm an academic, but I'm also known for other things that I did in the past, like my involvement in open source projects or writing for Oracle Java magazine. So briefly about Golo, we have two main goals. So the first goal is to be a language that is simple to use. And I love to say that it's a language that was made by academics, but for normal people, so that regular people can use it. But it's also a language that is simple to hack. And by simple to hack, I mean that it's a language that is a great platform if you want to learn about language design on the JVM. So if you don't know anything about it, it's a language that you can pick up pretty quickly if you want to get back on track. So just talking a bit about history. It all started before that with another project, which we presented at Devoxx France in 2012. This project was called Joufflu. It was some kind of aspect-oriented framework for the JVM. And with my colleague Frederic, we did a 1-hour talk using only hello worlds. But this is how we got started with InvokedYnamic. And then just a few months later, I said, well, the way we were using InvokedYnamic was not what InvokedYnamic was meant for. So I started to make a small hack, which was a kind of language, just to see how, to understand more about how InvokedYnamic works. And then a month later, Fibonacci was working. And as an academic, I love when Fibonacci works. So then there was basically no way back. I had to go to the end and then share the project so that everybody can understand how to make a simple language on the JVM. So enough of slides. Now it is time for demos. So the first thing is we have a single command which is called Golo. And you can run Golo. And we have many subcommands. So for example, we got a subcommand to compile code to JVM bytecode, which is very useful if you want to call Golo code from, say, Java or Groovy. But we also have a Golo subcommand if you want to dynamically execute some code from the source code without compiling it. So of course, I have a hello world example. So you can see that in Golo, we have modules. So you have to name the module for your source code file. We've got functions. Functions can take arguments. And you see that we use pipes, which is pretty familiar to the guys who know Ruby. So it's pretty much the same. We can declare constant references using let. We can have mutable references using var, which does exactly what you would expect. So you cannot reassign let, but you can reassign vars. We also have local functions. So local functions are simply functions that cannot be re-exported to other modules in Golo. And because this function consists of just a single expression, we can have this, this lambda-style arrow notation, because this is basically a one-liner. So I can show you that Golo actually works. So I can say Golo files and say demo1, and it works. Amazing. So I have another bunch of examples. This example is about to showing you how we can call existing Java APIs from Golo. So you can see that, for example, I can use linked list, which is coming from java.util. And the thing is, we don't have a new operator like you have in Java or similar languages. You can just, you instantiate objects by using the constructor as if it was a function. So you say linked list instead of new linked list. Then if you want to call methods, we have this notation, which is not a dot notation. So I know that not everybody agrees with that. But in our case, we chose to do it because it distinguishes between method invocations and function calls. And then you see that, for example, we have a for each loop, which would here just filter the elements that would be odd. So if I run it, oops, you see that we get 1 to 3 and 1, 3, which is what you would expect. So speaking about reusing existing Java APIs, we can do some things that are not part of the standard APIs. So for example, on list, you can append elements. So this is not something you find in the original Java API, because on list, you have an add method. So you have to say add 1, add 2, and so on, because the add method is void. In Golo, we provide you with an append method, so you can append a bunch of values at once. And we also have a filter method, which can take a predicate, which is passed as a function, so as a kind of lambda function, and you can filter elements. So this works as well. So you can say third demo, you get 1, 3, 5, which is what you would expect. So this is not magic. This is working using a mechanism we have in Golo, which is called augmentations. And augmentations are pretty much like what you have in C# with extension methods. So the idea is that, well, this is another example that I have. So let's say you would love to get the content of the Google Plus page, and you'd love to say, well, page to URL, get content, and read fully. Say you'd love to get this expression. And the thing is, when you have a string, you don't have a to URL, and when you have an input stream, you don't have a read fully method. So if you want to do that in Golo, you say augment, you specify a Java type, and the type can be either an interface or a real class. It depends what you want. And to add methods to types, the only thing to care about is that the first argument must be what we call the receiver object. So the receiver is the object you will invoke the method on. It's as simple as that. And same thing, we can augment input streams to have a read fully method, which takes all the content from the stream, puts it into a string buffer, and then gives it back to you as a string. So I don't know if network is working, but if it's working, it should be fine. So maybe we'll get the page of Google+. Yes, so we get a whole bunch of HTML and CSS all compressed. Fine. There is a fifth demo. So the fifth demo is about data literals. So for all the common literals you may be dealing with, like list, maps, and so on, we have literals, which are pretty simple. And because these literals map to collections, we have augmentations as well. So Golo comes with a bunch of standard augmentations on the common types like collections, files, streams, and so on. And you can, for each element of a given piece of data, you can have a toString. So here we can just print the value and print the class, just to show you what it's like. So if I run this, you can see that in Golo we just reuse we didn't reinvent our own classes for collections. So for example, when you have list, we have linked list. When you have vector, we have array list, and so on. You see that when we have an array, it's a Java array. The only thing is we have tuples, and tuples are basically a class that we provide, and it corresponds to an immutable array, basically. So that's fine. And speaking of manipulating data, we have some helpers to deal with Null. So as you probably know, Null is complicated. So let's say that I have a data model which is based on maps. So I have Mr. Bean with an email and a URL. Say that I have Larry, and Larry just has an email. He doesn't have a URL for some kind. So then I can get Mr. Bean, I can get Larry, and the thing is, I have this or is null operator. So the way it works is pretty simple. When the left-hand side is null, then the expression value is the right-hand side. So it could be NA. And in the case of Larry, because Larry doesn't have a URL, what you get back is NA, because when you get URL, you get null. So this is fine, and you can combine it with something that the Groovy people have in their language, which is the null-safe invocation of methods. So this is somehow the Elvis operator. And the idea is that you will invoke here the street method only if the left-hand side is not null, and you can chain it, like street and number, they will be invoked only if it's not null. And you can combine this with the or is null expression. So you can have this whole chain of method invocations, and if either the element on the chain is null, then you will get a default value using or is null, which I think is fine to do it now. So in this example, you see that it worked for Mr. Bean. We got the URL, and for the other elements, we got just NA. So I think it's a fine way to deal with nulls, because it's something we have on JVM. So a demo wouldn't be a good demo unless we had some GUI at some point. The thing is, I don't know about JavaFX, and I don't know about people who know JavaFX, so I just wrote some swing code. I'm going to show you the app first. So it's a pretty simple application. It's a huge button. So you see that all my life is about doing hello world. And whenever you click, you get something on the console. So that's fine. So what I wanted to show you here is that the action listener is being implemented by using a closure. So in this example, we just had the event and then we print on the console. And the thing is, because action listener is an interface with a single method, you can convert a closure, which is the first class citizen argument in Golo. You can convert it from a closure to some instance of the given interface. So that's how it works. The next demo is about matching. So we have a match operator in Golo. And for example, I have a what it could be function. And I'd love to have some kind of business rules to evaluate elements from a collection. So the idea is that match has when expressions, and a default clause which is otherwise. So something I'd like to say is that it's not like pattern matching in Scala. So in Scala, you have a real pattern matching. In Golo, it's just a glorified bunch of if-else statements. But still, it allows you to write some arguably readable code. So if I try to run this, that was demo, how much? 7. You see that it matches a bunch of elements. So basically, it's just a way to have if-else statements in a way which is a bit more readable. But because it's equivalent to a bunch of if-else statements, the order of their when clauses matters a lot. So what's the next demo? So in Golo, we don't have objects per se. We don't have true objects, but we have dynamic objects, which is the first form to make objects. So dynamic objects, they are like groovy expander objects. So you can add new elements to object definitions. So we have the define method, and you can define an entry. And for example, here value, not int, value, is 0. So this is recognized as some kind of property. So the idea is that because I have value which is defined like that, I get a getter method, and I also get a setter method with the same name and which is taking an argument. And when you define some property, and the property is a function, which is a closure, so if you do that, then this becomes a method. So in this example, I'm able to define an object dynamically. I have a getter on value, and I have inc, the incre method. So I could increment the value twice, and then I would be able to print the value. So that's a simple way if you want to make objects in Golo, but it's not the only way. There is another way, which is structs. So it's pretty simple. If I want to make a point with a struct with x and y, I can just say struct point equals x and y. And the cool thing is that structs are being compiled to real classes on the JVM. So because of that, first I get getters and setters for free. I also get a copy method, an immutable copy method, which is fine. I get a toString implementation for free, and also I get semantically correct hash code and equals methods. And also because it's a real type, I can augment it. So I can, for example, have this moveBy method, which allows me to write, say, 0.11, and then I can move it by some kind of increment. So it's a simple way to make objects, and if you know about Google Go, which is a language that I think is really interesting, it works exactly the same way. So you can define object with structs, and then you can have methods being applied to the object. So if I run it, it must be the 9th, right? You see that, okay, good news, you get to string method. Next demo is a web demo. So I said that you had to have a GUI at some point. You can have web applications too. So first I'm going to show you the application, which is not a complicated application. So it's running locally, and it's a pretty simple example. Oops. So you can say hello debuggs. Basically, it's just a board of messages. So you can push stuff, say hi, hello Guillaume, and so on. Well, you could do many things like that. So the thing is, there are two things that I wanted to show you here, and a third thing as well. So first, I don't know if you knew it, but within the JVM, you have some com.son class, which allows you to have an HTTP server. So if you have simple needs, you don't really need to have JT or something like that. You can just read this class. So the first thing I wanted to show you for real is the templating that we have in Golo. So you can have you can have a big string, and you can embed Golo code pretty much like you would do in JSPs. So this is how you could define a template in Golo. When you want to use the template engine, so you get a template engine, and then you can compile a string to a template. And the nice thing is that the index TPL reference that I would get is a function. So if I want to call the template, I would just call it as a function and pass arguments to the template, like a regular function call, and this will give me back a string. So for example, I can show you that there is a function which is called indexed, unsurprisingly, which is able to handle the whole routing logic. And I can just call template as a function. So that's quite nice. And the other thing that I wanted to show you is how we do, say, dependency injection when we don't have objects. So you see that index is the function that is going to be called by the HTTP server API. In reality, it only takes an exchange parameter. It doesn't take post or template. So when we want to do that, we do what we do in functional programming languages. We do partial application. So using bind to, you can partially apply some arguments. And then when what you get back here is just a function which takes a single argument, which is fine for the API. So that's how you would do this in Golo. And I have a last demo, which is simple, which is using a micro web framework called Spark. So what I wanted to show you here is how you can integrate with third-party APIs, because there are some third-party APIs that want you to implement some kind of interface or extend some object. So in Spark, which is a micro web framework, if you want to deal with HTTP requests, you have to, at some point, extend spark.root, which is a class, and you have to implement a handle method, which takes a request and a response. So in Golo, we don't have classes, and you cannot say this class extends something. But we have an API to specify at runtime, well, to define dynamically at runtime classes. So it's called an adapter fabric, because I didn't want to name it factory, because it sounds a bit like Java EE stuff and so on, Spring stuff. So I said, let's call it adapter fabric. You can pass a fabric, a configuration as data, and this gives you a maker, and the maker is a factory object. So Spark wants some kind of root object, and you just say new instance and from the maker, and this is going to create 2 instances. So this is how you would make Spark happy, by giving it an object that extends spark.root at some point. So just to show you how it works, so that's demo 11th. I have to specify a class path, because Spark comes with a bunch of jars, so I say Spark start.jar. And there is an argument, which is the message that's going to be print. So I'm going to say, hello, devox, you rock, something like that. And of course, it didn't work. So, oh yeah. Thank you, Guillaume. Yeah, thank you, Groovy. So, so if I go to my application, so I know you know that it's going to work, but you see that we had some integration between. Thank you, Guillaume. Thank you. So we had integration between Golo and third-party APIs. So this example was pretty simple. We just have a class to extend, and then it works. But you can do more fancy stuff like doing proxies, or because you can get the original method implementation as an argument to do overrides. So you could do proxies and stuff like that. So if you look at the Golo distribution, we have some samples that show you how you can make more fancy stuff. So this was about demos. Now I wanted to talk a bit about benchmarks. So Guillaume, don't get angry. This is not a shootout between languages. So I'd love to say this. I just want to compare specific portions of the Golo runtime against similar code in other languages. But in any case, you never choose a language based on stupid micro benchmarks. So we have a bunch of languages. The thing to note is that I never use tricks in these languages. I just try to make similar constructs, which is not always easy. And when some languages support type annotations, I don't use it as well, because in Golo we don't have type annotations. So languages with type annotations would be faster with the same expressions, but we didn't do that. So the first benchmark is what we call monomorphic dispatch. And if it scares you, don't be scared. It's pretty simple. Just imagine that you have a bunch of objects, like 12 elements. You have a for loop over the elements, and you want to call the toString method on each element. So this is a monomorphic call site because you always dispatch toString to the same class. So in this case, you can see that Golo has Java-like performance. If you get to a trimorphic call site, so again, we have a collection, but there are 3 different classes in the elements. We stay Java-like as well. There is a worst-case scenario, which is a megamorphic call site. So every element is from a different class. So in this case, we are not Java-like anymore. We have to change the method dispatch strategy. But if you look at the graph, it stays quite okay, I would say. So what else do we have? We have Fibonacci, the king of benchmarks. So Fibonacci, you can see that no dynamic language can, without type annotation, can match Java, which is what you would expect on the JVM. But the thing to note is that if you look at Golo and Java with boxing, we have more or less similar performance. So we are slower, but it's not too bad. And especially what we have to deal with in Golo is boxing. So we spend all our time doing boxing and unboxing of objects, which is really hitting performance. We also have a filter map reduce micro benchmark in the code. So that is that you do first a filter operation on the elements of a collection, then you map the values, and then you just reduce it. So here you can see that we have good performance. And the last micro benchmark is about dynamic object dispatch. So in this case, you can see that Nashorn, which is the JavaScript implementation by Oracle, shines, which is good news, because JavaScript is all about having some kind of hash maps and weird objects. You can do crazy stuff with that. So our performance is not too bad as well. I want to speak a bit about the tooling as well. So although Golo is a very young project and pretty much an unfounded project, we have some enthusiasts who did a bunch of cool things for us. So we have an Eclipse, NetBeans, IntelliJ support. We have support for the major build tools as well, be it Maven or Gradle. So as you know, in open source, whoops, I went too fast. So in open source, it's all about having enthusiasts in the community. So I'd like to take a moment to thank them all. So there are a bunch of people here, but there are more people, especially people who tested or people I discussed with ideas like Rémi Forax or Guillaume or people like that. So I'd love to thank them all. And that's it. So we have time for questions. And thank you very much for attending this session. And there's a QR code if you want to flash it. There's a surprise here. It's not what you would expect. Yes?
So this is not a question you can answer here, but where can I find resources about the whole dynamic invocation process?
About invoke dynamic. So
how you use it?
Well, if you want to know about the way we use dynamic invocation, well, I don't really understand your question. You can look at the source code. But the thing is, every call site, so whenever you want to call a method in Golo, we use it using invoke dynamic. So every call site, every method dispatch, or even operators, they are using invoke dynamic. Does that answer your question? Okay. Yeah. So the question was, can we have local augmentations using the local keyword? And the answer is no. Not at the moment. So when you define augmentation, it's visible within the same module and within the modules that you import. Okay, so if you import a module with augmentations, you get to see it. Maybe that could be a pull request for you. I don't know. Yeah, Guillaume.
The augmentation on the struct, does it add the method to the real class that you are generating, or is it just a dynamic augmentation?
Okay, so the question was, basically what happens when I do an augmentation on struct? So it doesn't add method to the struct class. So it's not like in Groovy where you have meta classes. It's not the same mechanism. So the way augmentation works is they are syntactic trigger, basically. So no, it doesn't have methods. It's only method that become visible if you had the augmentation that is visible from your model. Okay. Another question?
You only have shown some simple examples. You have planned for Golo Enterprise Edition?
Question was, do you have plans for Golo Enterprise Edition? I think we would need to make the type and safe company first. So I don't know. Well, I think at some point it has to come from the community as well. So my life is about showing hello world. But if people have real needs, maybe we can have some kind of type and safe examples for Enterprise Edition of Golo. I don't know. Could be GEE. I don't know. GJB. Another question? No. So thank you very much. And I have some stickers.